Hey y'all, in this lesson, we're going to be using Venn diagrams to visualize set operations. In my last video, I went over the different operations. So like intersection, union, complement, subtraction. I went over those things using a Venn diagram and shading. So I want to use that to go over these 4 examples. And before we do these examples, let's build a Venn diagram for the sets that we have listed here. You will have 3 different circles in your Venn diagram. So your 3 circles are going to overlap. All overlap because they all have elements in common. So I want you to first build your Venn diagram and then we'll go over the examples. Once you've built your Venn diagram, it should look like this. And I want to kind of give you some tips for building a Venn diagram when you have a lot of sets with some overlapping. So I usually just start with this first set. And the first element in that set is A. And you look at the other sets, and the other sets share A. So that has to go in this portion right here where all 3 ovals intersect. Then you do C. C is also in B, so that goes here. E is also in C. I should have used numbers instead of letters. It's getting confusing with all the letters, but that's how I built those. And then the last thing I need to do is I need to check and make sure that I've used all of these letters. So I know I have A, B, C, D, E, F. I skipped G, I guess. H, I, and J. So there's nothing else I need to write. If there had been a G up here, I would need to put it out there so that it is still included in the Venn diagram. So if I were to now practice these operations, then I can use my Venn diagram as a visual representation of that. And I'm going to try to use some highlighting also, which I can erase for each problem, hopefully, and not get too messy. So the first example says, where does A intersect B? Now you can look at your list, you can look at your sets that are listed out, and that's fine. But we can also look at the intersection of the 2 circles in our Venn diagram. A and B, the sets A and B have A, lowercase a, and lowercase c in common. So that's the intersection of the 2 circles. Then for the next one, it says the complement of A. So the complement of A means everything not in A. So if this is A, then all of those letters in green, teal, mint, I don't know, all of those letters live inside A, which means that the complement of A are all these letters out here and in the universal set, but we don't have any letters in the universal set that aren't in the circles anyway. So I'm focusing on all the red scribbles. Any letters in those regions are the complement of A. Complement of A is everything not in A. So that's going to be D, F, I. The next one is C minus A. So if you can kind of visualize it in your mind, you have the circle of C and you're pulling A out of it. So you kind of picture it like 2 cookies overlapped, I don't know, and you're pulling one off or you're taking a bite out of it. So we're going to take A and we're going to ignore everything inside A because we're subtracting it out of C. And that leaves D, F, I. And then the last one, we've got several different operations going on here. We have A union B minus C. So first we want to think about the parentheses, A union B. A union B is the union of both sets A and B. which means that we're going to be looking at all of the elements. We're joining by union, by way of union, sets A and B. But then we're going to subtract out, pull out C. So I'm going to kind of hide those. And then you write what's left over. And it looks like the only elements left over are C, J. So whenever you have multiple operations here going on, you want to kind of deal with it kind of like PEMDAS, kind of like order of operations. We're going to deal with this parentheses first, then the subtraction last. That's all I have for this lesson. I hope it helps. If you have any questions, let me know and I'd be happy to answer. See you in the next one.